Right, now that we know what a square and square root operation does to a number, we can start looking at what it would mean to have a non-perfect square or a non-perfect square root and how to approximate that, okay? So we're going to title this video, this is still week 1 redo of asynchronous videos, but this is going to be about approximating square roots. Okay, so let's first think about what does it mean for something to be a perfect square? Well, a perfect square is kind of any square that you can draw on your graph paper nicely that's going to end up where you're tracing the exact graph paper lines. So for instance, 1 squared makes this singular little box. So 1 squared, or 1, because that's the answer to 1 squared, is a perfect square. Or for instance, if you have 2 squared, well, that gives you 4, meaning that 4 is a perfect square because it makes a perfect square on my graph paper here, okay? So that would be 2. And you don't have to draw them over each other like I'm drawing right now if you don't want to, okay? But adding this area, well, that makes 2 squared, okay? Well, let's say I have 3 boxes going in each direction. Well, that would mean that I have 3 squared, and that gives me 9 total shaded boxes, so 9 is a perfect square. So anytime you take a whole number, okay, a whole number, so 1, 2, or 3, like in my examples, and square them, you will get a perfect square. So anything that we've made in your lists in the past that are in your notebook, those are all perfect squares, okay? And so if you think about it, if you're doing the opposite, if you're looking for like a perfect, actually, let me put it this way. If you're square rooting a perfect square, you will get a whole number. So if you square root a perfect square, you will get a whole number. So let me write some examples of this. So for instance, the square root of 9, well, 9 is a perfect square, so that's going to give me a whole number, which is 3. The square root of 4, well, 4 is a perfect square because 2 times 2 is 4, so I would get 2, which is a whole number, okay? So the issue is that we can always know what the square root of a perfect square is, right? Like, let's say I'm taking the square root of 64. Well, 64 is a perfect square because 8 times 8 is 64, so I know the answer is easily 8. But if you have the square, if you're trying to know what the square root of a number is, like 72, and that's not a perfect square, right? Like 8 times 8 is 64, but then I go to my next whole number, which is 9, and 9 times 9 is 81. So there's no 72 on my perfect squares list. If I had kept going up here with my perfect square list, I'm never going to get to exactly 72. But I will know what it's between. So the way to think about being able to answer this question is like approximating the square root of 72. Well, you would want to think, what 2 perfect squares is it between? And like I said, we know that, well, 64 is just below it, and 64 is a perfect square. That's 8 squared. And 81 is just above it, and that's 9 squared, right? 72 lies somewhere in the middle here, which means that if I square root all of these, so if I do the square root of 64, well, that has to be less than the square root of 72, which has to be less than the square root of 81. Well, the square root of 64 is 8, and the square root of 81 is 9 because of what we set up over here. And so that means that we know that the square root of 72, if we were to actually try and answer that, it has to be somewhere in between 8 and 9 on a number line. And so we could say the square root of 72 is between the whole numbers 8 and 9. Okay, a whole number is typically just your counting number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You can keep going, but they don't have decimals and they're not negative. So they're exact whole number answers. But let's say we want to get even more specific. Let's say, okay, I know that it's in between 8 and 9, but now I want to know, like, is it closer to 8? Is it closer to 9? Like, what's my first decimal place going to be? So let's just stick with this example. So let's say I want the square root of 72, but to the nearest tenth. Well, the tenths place is one decimal place into a number, so I already know that this is going to be in between 8 and 9 because the square root of 64 is 8, and the square root of 81 is 9, and 72 lies between those two numbers on a number line. But to be more exact with our answer, because we know it's going to be 8 point something, we can look at the difference between 64 and 72. Well, the difference there is going to be 8. And the difference here between 72 and 81 is 9. And so 8 and 9, right, that means that 72 is pretty much in the exact middle of 64 and 81. Well, then I would have to think about, okay, what's in the exact middle of 8 and 9? So if I was to put 8 and 9 on a number line, right, if I was to call this 8, well, this might be 8.1, 8.2, 8.3, since I'm counting by tenths, 8.4, 8.5, 8.6, 8.7, 8.8, 8.9, and 9, right? So I'm kind of looking at something in between 8 and 9 perfectly on this number line, because 8 and 9 is the difference between 72 and 64 and 72 and 81. These two numbers are not always the same, they just happen to be the same in my example. And so I would notice on my number line that 8.5 is pretty much in the dead center between 8 and 9. And so that would be a really good estimated guess on the fact that 8.5 squared is probably really close to 72. So you could go ahead and check and make sure that your answer is decently accurate. So to do this, you would say, well, 8.5 times 8.5. Well, 5 times 5 is 25, so 5, and then carry your 2. 5 times 8 is 40, so you put 2 and 4s for 42. You put your 0 down here because now you're working in the ones place, then you would do 8 times 5, well, that's 40, so 0, carry your 4. 8 times 8 is 64, and then add that 4, so you would have 68. So now all you have to do is add these together, so that would be 5, 2, 12, carry your 1, and 7. And then since we have 2 decimal places in our problem, we need 2 decimal places in our answer. So it's 72.25. So since 8.5 squared is equal to 72.25, we know that that's super close to being 72 exact. So we should call this good enough for our answer, and our answer is 8.5. Hopefully this helps you kind of understand what your process for approximating a square root should be. If you don't have any of this written down right now, go ahead and pause the video and write it right now. If you ran out of room right here in your notebook, kind of how I ran out of space on my pages, go ahead and put the rest of the next example on the next page.